Good morning everyone. In this video we will discuss about the parabola with vertex at h and k. So we have here the parabola with horizontal axis of symmetry with the equation of the quantity of y minus k squared equals 4p times the quantity of x minus h, and its characteristics that follows. We have focus on this point and the opening of the parabola. If p is less than 0, the parabola opens to the left, or if p is greater than 0, the parabola opens to the right. Also, for the latus rectum, we have the equation of the parabola with horizontal axis of symmetry. We have here the direction of the latus rectum. It is vertical, and the length, it is equal to 4p. If you're going to divide the length into 2, it will be 2p and 2p. If we're going to add it, it will be equal to 4p. So the endpoints of the latus rectum is defined by points h plus p, comma, k plus 2p. And for the axis of symmetry, we have equation is equal to k. Direction, it is horizontal. Next, directrix, we have x is equal to h minus p. This is the equation for the directrix, and for the direction, it is vertical. And for parabola with vertical axis of symmetry with vertex at h and k, we have the equation quantity of x minus h squared equals 4p times the quantity of y minus k. And for the focus, it is on the point h, comma, k plus p. And for the opening of the parabola, if p is less than 0, the parabola opens downward. And if p is greater than 0, the parabola opens upward. So for the equation of the latus rectum, we have y is equal to k plus p, and its direction is horizontal. Length also equal to 4p, and the endpoints is on the point or points quantity of h plus and minus 2p, comma, k plus p. And for the axis of symmetry, x is equal to h, direction vertical, and for the directrix, the equation is equal to y equals k minus p, and the direction is horizontal. So for the solution of y is equal to negative 1/4 times the quantity of x minus h squared plus 2, we have it here. First, we will rearrange the equation or the terms found in it, just like the one that we can found or see in the table I shown you a while ago about the vertex or the equation of the parabola with vertex at h and k. Or we can also apply the addition property or subtraction property of equality. But here I just use the process, the layman's process, which is transferring or transposing values. So I just transpose or transfer positive 2 on the other side of the equation. That will give you negative value of sine of positive 2. So we have negative 2 here is equal to negative 1/4 times the quantity of x minus h squared. Next, I will write this again by arranging this just like the format of the parabola with vertex at h and k, which is in the form of quantity of x minus h squared is equal to 4p times the quantity of y minus k. So we have it here. Negative 1/4 times the quantity of x minus 8 squared is equal to quantity of y minus 2. So for us to eliminate negative 1/4 here or negative 4 here, we will divide both sides or multiply both sides of the equation by negative 4. So negative 4 times negative 1/4 is equal to 1. Since negative 4 times negative 1 is negative 4 divided by negative 4, so we have positive 1. And also, quantity of y minus 2 times negative 4 is equal to negative 4 times the quantity of y minus 2. So we have now this form of our equation. And we can directly identify where is k and where is h and where is 4p. So in this format, we have h here in the side of x and k with y. And also, the value of 4p is equal to negative 4. So for us to find the focus, we have the point h comma k plus p. So for h, we have positive 8. Since negative here is constant, so the opposite value of 8 here will be the value of our h. And for the second value, or for the x value, or y value rather, we have k plus p. So k is equal to positive 2, which we have here. And for p, we can obtain p. We can obtain p by just getting the value of 4p, which is equal to negative 4. And we will just divide both sides of the equation by 4 to get the value of p. So we divide this by 4, and here also divided by 4. So we can cancel 4 here and in the denominator. So we have p, and negative 4 divided by positive 4 is equal to negative 1. So now we have the value of p, which is equal to negative 1, and we will just substitute this into our equation or formula, which is k plus p. So we have it here, 2, which is equal to k, plus the value of p, which is negative 1. So positive times negative 1, we have negative 1. So 2 minus 1 is equal to 1. So therefore, the focus is on the point. And for the equation of the directrix, we have y is equal to k minus p, and k is equal to 2, and our p is equal to negative 1. So we will just substitute those values of k and p. So we have minus the value of p is equal to negative 1. So negative times negative is equal to positive. So we have 2 plus 1 is 3. So the equation of the directrix is y equals 3. So for the graph of the parabola and the directrix and its focus, we have it here. First, you have to draw the Cartesian coordinate system with x-axis and y-axis, and also label your graph with the needed data we have here for the values of x and for the values of y. And since our vertex is on the point h and k, we will identify first what is the point of the vertex. So h is equal to 8 from here. So h here is positive 8, since negative value or subtraction is constant. And also for k, that is equal to the value of k here. So this is positive 2. So we have it here. And we will locate it now. So we have 8 and 2. Since we have now the vertex on the point 8 and 2, we will now locate the point of the focus, which is 8 and 1. So we have here 8 and the intersection of 8 and 1. So we have it here. And I drawn here the latus rectum. So next will be the line of our directrix. So we have it here. So 3, y is equal to 3. This is the equation of our directrix. Don't forget to label your graph. Take note, class, that p is less than 0, so it opens downward, since p is equal to negative 1. So what if we have this equation, which is x equals negative 8 times the quantity of y minus 2 squared minus 4. How are we going to find the point of the focus and the equation of the directrix? For the solution, let's talk about that on this video. So we have here the solution for the equation x is equal to negative 8 times the quantity of y minus 2 squared minus 4. First, we will arrange or rearrange the equation into this form. So we have x plus 4. So positive 4 was from negative 4 here. So I transferred negative 4 into the other side of the equation. That will give you positive 4. And what will be left on the other side is negative 8 times the quantity of y minus 2 squared. So next, I rearrange this again into the form of y minus k squared equals 4p times the quantity of x minus h. So we have it here. However, we still have negative 8 on the other side, or on the left corner of our equation. So for us to eliminate negative 8, we will divide both sides by negative 8. Why so that we divide both sides by negative 8? Because we need to eliminate this negative 8 here. There should be no number other than 1 in this equation, or in this side of our equation. It should be like this. So quantity of y minus k squared. You cannot see any number here at the side of this expression. So we will divide both sides by negative 8. So negative 8 divided by negative 8, what will be left is quantity of y minus 2 squared, and x plus 4 divided by negative 8 is equal to negative 1 over 8. Why we have negative 1 over 8, and here we have only negative 8? Take note, we have 1 here, but you cannot see that, because in mathematics, if you only have 1 here in multiplication, for example, 1 times 2 is equal to 2, you cannot see 1. Take note that there is always a factor of 1 in every expression or whole number. So we have negative 1 over 8 times the quantity of x plus 4. So this is now in the form of y minus k squared equals 4p times the quantity of x minus h. And here we can now identify the vertex in the point h and k. So the vertex here is, for h, we have negative 4. Since the original equation told us, or dictates, that we have y minus k squared is equal to 4p times the quantity of x minus h. So we have here the constant operation, which is subtraction, and you have here in our process positive. So what will be the opposite value of our 4 here, or number here, will be the value of our h or our k. So since we have positive, it will be negative. Since we have negative, it will be positive. So we have positive 2 here. For h and k, we have negative 4 and positive 2 respectively. And next, we will now find the value of p. Take note, negative 1/8 is equal to 4p. So 4p is equal to negative 1/8. We will divide both sides by positive 4, since we are going to find the value of p. We will eliminate 4 together with p. So we have 4p divided by 4 is p. Negative 1/8 divided by 4, we have it in this way. Take note, in dividing fractions by whole number, we will just copy the denominator, and we will just multiply the reciprocal of our denominator into our numerator. So we have negative 1/8 times the reciprocal of 4, which is 1/4. So negative 1 times 1 is negative 1. 8 times 4 is 32. So the value of p is equal to negative 1 over 32. And for the points of the focus, or the point of the focus, we have the quantity of h plus p is equal to k. Or no, quantity of h plus p, comma, k. So we have h is equal to negative 4 plus the value of p, which is negative 1 over 32, comma, the value of k is 2. And we will combine, or we will now simplify negative 4 plus negative 1 over 32. So we have here 32, and the denominator of negative 4 is 1. So we will get the common denominator, or least common denominator, which is 32. 32 divided by the denominator of negative 4, which is 1, is 32. So 32 times negative 4 is negative 128. And 32 divided by 32 is 1. Times negative 1, we have negative 1 here, comma, 2. So negative 128 minus 1 is negative 129 over 32, comma, 2. So we have now the point of our focus on negative 129 over 32 and 2. So this is now the answer for the focus. However, I gave you here the estimated value of our focus. This is just for the benefit of our graph. but I will not require you to do it this way because I am requiring you to do it in this way. If the given is fraction, you should remain it as fraction, or you should write it as fraction. I just give you this because I just want you to be clarified of the position of our focus later in our graph. And for the directrix, we have x is equal to h minus p. This is the equation of our directrix. So h is equal to negative 4. We have it here. Minus p is negative 1 over 32. So negative times negative, we have positive. And again, we will combine this by getting the least common denominator, which is 32. So 32 divided by 1 in the denominator of negative 4 is 32 times negative 4, negative 128. 32 divided by 32 is 1 times 1, so we have 1 here. So negative 128 plus 1 is negative 127 over 32. For the location, or for the plotting later, we have negative 3.97. So for the graph, we have it here. Since p is less than 0, it opens to the left. So we will just do an estimation. This is the vertex on the point negative 4.03 and 2. And for the focus, vertex is equal to negative 4 and 2. While the focus is on the point negative 4.03 and positive 2, the intersection of 2 and 4.03. And for our directrix, it is in vertical manner. So the equation is x equals negative 127 over 32, or x is equal to negative 3.97 in the location. So that's it. But don't forget to write the x and y axis. Don't forget to label your Cartesian coordinate system.